Hey guys, okay, hope you enjoyed that short clip earlier. Now that you are able to see why do stars actually twinkle, okay, as well as this little trick over here, how why pencils when they're put in a cup of water they actually do bend. Okay, so that's basically because of refraction, also known as bending of light. Okay, so we are right now on the refraction 10.2, or in your chapter will be 2.2. Okay, so refraction is the bending of light as light passes from one optical medium to another. Okay, so just a quick recap. Okay, this actually everything is still pretty much the same. You can actually see here the angle of this is the air glass boundary over here. Instead of having a mirror, the normal is the imaginary line, dotted imaginary line that is perpendicular to the surface. So incident ray, refracted ray. Okay, so a ray that comes in, the angle of incidence is measured with respect to the normal, and the same thing goes for the angle of refraction. Okay, so laws of refraction is pretty similar. Okay, first law states is the same, that the incident, normal, and refracted ray are all in the same plane. That means that they are actually on two dimensions. Okay, we don't see that in 3D. Okay, the second law of refraction, sorry, okay, states that for two given media, the ratio of the sine of angle of incidence to the angle of refraction is a constant. Okay, this constant also known as the refractive index. But I wouldn't really confuse you at this point in time. I just want to introduce you these two new formulas for refractive index. Okay, what is refractive index? Okay, refractive index of a medium is just defined as the ratio of the speed of light in vacuum to the speed of light in medium. So, as you can see, speed of light in vacuum is c, speed of light in medium is v. We know that speed of light in vacuum, it will definitely travel faster in vacuum, so c must be greater than v. Since c is bigger than v, n value, or also known as the refractive index, will always be a number bigger than 1. So in your calculations, if you find that your n value is less than 1, you need to recheck your work. Just make sure that you don't miss out any steps or any part of the formula. Okay. Second formula over here, regarding refractive index, is psi I over psi r. Okay, just to take note, your I and R, it doesn't really mean a incidence or refraction, but it basically means that one of them is the angle in the vacuum, the other one is the angle in the medium. Okay, so basically, for example, if you are talking about air into this in the figure below, which is the optically denser medium, P or Q. Okay, so let's say this is a medium. Okay, let me just zoom it in. So if P is the medium, this angle is your I, this is your R. If I'm looking at the other side, this will be my I, this is my R, because my R is the angle of refraction in the medium, whereas this one, the first one, is angle of incidence in vacuum. Okay, just a point to take note. Okay, since the speed of light in vacuum and in air is almost the same, and on Earth it's very difficult to actually, we don't really see vacuum in a lot of nature, so we actually take the speed of light to be in air and vacuum to be similar. Okay, so the higher the value of the refractive index of a medium, the smaller the angle of refraction. Okay, so what does this make sense? Okay, for example, over here, why do we know that? You can see the light ray, this is the original direction of the light ray, but it actually bends after being refracted in diamond, it actually bends towards the normal. For water, it's the same case, but it doesn't bend so much. You see, you can see this is the original direction, whereas this is the original direction. It actually bends it further in diamond and less in water. Okay, I'm going to just stop here and show you how do we decide whether the light ray actually bends towards the normal or away from the normal. Okay, just want to show you a short clip over here. Okay.